Okay, Rahul, are you there?
Yes, sir.
Yes. So have you accessed the PC using any desk?
Yes, sir. I am on the desktop now, sir.
Okay. I will just tell you how to invoke the tool, okay? So
Yes.
you just listen to me. And those who ask doing this for first time, they can also listen here. So I'm just sharing my screen.
सर ऑफलाइन है ऑफलाइन सर चाबी दे रखी है अपनी तो लॉबी मधून हे होतं ना सर चेक होतं सर इकडच्या साईडला आहे का इथेच बस हां सर यहाँ पे कौन है लॉबी पे
Okay, now Rahul, listen. First, create your name folder here. While giving the
Yes,
name to
sir.
the folder, don't give space in between. Okay. So if I'm creating a folder here, I'm giving the name Chetan. Okay. Chetan 1. Okay. I have created the folder. Now go inside the folder. And now, if you want to create an inverter design now, right? So for that particular design, create one folder, inverter. Okay. In that your name folder. After creating that folder, go inside that folder. Are you following? Are you doing?
Sir, I'm noting down the steps, sir.
You can parallelly do it. So, okay. ठीक है.
Yes,
You
sir.
can.
Sir, actually, I can't see the both on screen, sir. Like you are sharing your screen, na, sir.
Yes. ठीक
Yes,
है.
sir.
Now I have gone. I'm gone. So I am inside the inverter folder. Now I will do the right click, open in terminal. Okay. So I will open the terminal. So just like in Windows, how we open any app, we just double click on that app icon and that app will get open. Okay. So to invoke this tool in Linux platform, you first type CSH, okay, then hit enter, then source space slash home install CSHRC. Okay. After source, there is a space. Okay. And all the letters are small letters. Then hit enter. Okay. Then you will be into Cadence tool suite. Okay. So here you need to invoke the Virtuoso tool. We are performing this IC design flow using Cadence Virtuoso tool. Okay. So first, to invoke that tool, here you need to type Virtuoso. Okay, spelling should be correct, then only it will get open. Okay. So after typing the Virtuoso, enter. Okay, now this screen will get open, cds.log. So this is a log window of Virtuoso. If you want to check any errors or warning, those warnings will be visible in this window or errors will be visible in this window. So this is a log window. So there are different options like a file, tools, options, help. Okay. So for any design, for example, if I am to create an inverter, right? So in for that design, I need to create one library. Okay. So in that library, I will keep my test benches. I will keep my schematic. Okay. So for that purpose, I will go to the library manager, tools and library manager. Okay. So after going into tools and library manager, this window you can see. So this is divided into 3 sections. The
Hello,
library.
sir. Hello.
Yes.
Sir, can you explain once again, sir, after that source, home, install CHSRC, sir, in terminal window, sir. Actually, I have got disconnected, sir.
Okay. ठीक है. Again I will explain.
इसको भी बनाना है।
Okay, after entering that source space/home/install CSSRC, you can,
Yes, sir.
this window will come. Okay, welcome to Cadence tool suite. Now here you need to type Virtuoso. Don't do the spelling mistake here. And if you enter here, one log window will get open. Okay, is this visible log window? Yes.
Yes, sir.
So in this log window, different options are there, different tools are there. Okay. So to create any design, first you need to create a library for that design. Okay. And all other design parts you can keep into that library. So to invoke the library manager, I will go to tools and library manager. Okay. So now this is a library manager window. So in this window, there is a library section, sales section, and view section. Okay. So here you can see the different types of libraries are there. GPDK 90, GPDK 180, and other libraries are there. Okay. Now you need to create one library for yourself here, for your design here in this. So after creating that library will be get placed in the design library section. Okay. So for that purpose, first go to File, New, and Library. Okay. So after clicking on File, New, and Library, this window will open. So you need to give name to your library. So I am giving name Chetan Day2. Okay. Designs. Similarly here also, while giving the name, don't give the space in between. Then click OK. So after clicking on OK, one pop-up will occur, technology file for new library. Okay. So click on that pop-up. After clicking on that pop-up, there are 4 options. Okay. So from this 4 option, we need to select third option, that is attached to an existing technology library. Okay. So we need to add some library to our design. Okay. So here you can see there is a GPDK 90 and GPDK 180 libraries there. Okay. So those are generic process development kit. So what is mean by that? This kit means we have taken this Cadence Virtuoso from some firm. Okay. So while giving the license for the educational purposes, they give generic process development kits. Okay. So you can follow entire IC design flow, but you can't fabricate that particular unit in fabrication unit. Okay. That particular chip in the fabrication unit. Okay. So for that purpose, what you need to do, you need to ask fabrication unit that give the PDK of your fab unit so that we can construct a chip for that particular design. Okay, by using your foundry. So similarly, this we need to connect this our library to one of this design, GPDK 90 or GPDK 180. So what is mean by 90? GPDK 90 means 90 nanometer technology. So in that process development kit, the minimum channel length is 90 nanometers. Okay. Transistor channel length. Okay. Similarly for 180, that is 180 nanometer. So I need to select one of this PDK. So I click on OK. So here you can see different technology libraries are there. So I'm selecting GPDK 90 here. Then click OK. Okay. So after clicking on OK, you can observe that your libraries get added into the library section. Okay. Chetan underscore day2 design. Now library consists of different cells, right? It is a group of cells. Okay. So you can create a different design in that library. For example, if you want to generate a very, if you want to design a very big circuitry, okay, or any big design, we can say, okay. For example, any super heterodyne receiver kind of thing. If we talk about the communication, right? So there are different blocks in that, right? So those different blocks will be the cell of that particular super heterodyne receiver library. So you can properly connect those cells to each other while creating the super heterodyne receiver. Okay. So like that way we have created the library. Now we need to create a cell into that library. Okay. So for that purpose, first you should make sure that you need to click on that library first. Okay, whatever the library you have created. After clicking on that, there will be a dark section around it. Okay. So after doing that, you need to create one cell view. Cell view for that. So file, new, cell view. Okay. So after clicking on OK, one pop-up will occur, new file is ready. Okay. Any pop-ups which occur into this platform will be get settled up to the, so at this bottom place. Okay. So here you can see that pop-up is placed at the bottom place. So new file. So new file is the pop-up here after creating new cell view. Now in this new file, so it is saying that this new cell will be created in Chetan underscore day2 design library. Okay. So in my library, that cell will get created. So I am giving name to that cell. I want to create an inverter. So I am giving name to that cell inverter underscore plane. Okay. So and view of that should be the schematic view. Okay. Schematic means we need to create a schematic for that particular design and type should be schematic. And we are opening that with the application schematic L application. Okay. That is schematic L editor, which is present in the Cadence Virtuoso tool. And the library path file for that particular design is here. You can observe the path for that library file. Okay. So if I click on OK, they will ask you for license. Okay. So click yes here. So after clicking on yes, new editor window will open. Okay. So this window is called as a schematic editor window. Okay. So in this window, you need to create an inverter schematic, right? So in the inverter schematic, uh, just a minute.
ते बघतील.
Those who are familiar with the flow, they can implement a NAND gate design. Okay. And those who are new, for those I am repeating the things so that they can keep up with the space. Okay. So those who already know the flow, they can create their design. Okay. So as you know, in the inverter, there is one P MOSFET and there is one N MOSFET, right? Okay. So those things are called as an instance in this particular semantic part. So every component is instance here. So to take an instance, there is a shortcut key on your keyboard, I. Okay, type I. If you type I, the add instance window will get open. Okay. Now, first we need to take that instance from the library. So we have attached 90 nanometer GPDK with this, right? So I am browsing the library GPDK 90 here. Okay, and I will take a NMOS from there because I will require one NMOS and one PMOS. So in the from the after clicking on browse, I am selecting the library GPDK 90. In that GPDK 90, there are different components, okay, from resistor to capacitors. Okay, similarly, NMOS and PMOS are also there. So I will require NMOS. So I will take this first NMOS, NMOS 1V. Okay. So if you click on that NMOS cell, here you can see different views are there. So according to the different phases, like in spectra simulation view, SPICE simulation view, okay, those views are there. So I require a symbol view, okay. So that is tick on symbol only. So I will close this, okay. Now after closing that, here you can see I have selected the library GPDK 90 and my cell is NMOS 1V and view for that cell will be symbol. Okay. Now here you can give the name also to that. So if there is a larger design like 18 transistor, 26 transistor. So in that particular design, you need to give name to the particular transistors, right? So I'm giving name to this transistor M1. Okay. Here you can give the name. And after that, there are different fields for this particular instance. Okay. So multiplier is generally a thing which will be used when we want to reduce the height of the particular chip. Okay. Or we need to divide our transistors. Okay. Width can be get minimized, right? And here you can see length of this transistor is 100 nanometers. Okay. And total width is 120 nanometer. Here we are using only one finger. That's why finger width is 120 nanometers. Okay. Finger width will be equal to your total width, right? So that will be like a width of the finger. Okay. That will be the width of the finger. So this kind of we are not changing, we are keeping it default. Okay. So according to our design analysis, we can change width and length. Okay. So if you want to design any circuit, you need to design its width and length, MOSFET width and length. Then you can design that particular circuit. Okay. And different things are there like source and diffusion, source and drain metal width and all those things. Okay. So I will just hide this. After hiding this, to your cursor, one NMOS is get attached. Okay. Now, if I want to place this NMOS into this schematic editor, I will just place here. I will just click once, right? Now, if you want to come out of any mode, you just need to press escape. Okay. So after clicking on escape, I came out of that mode. Okay. So first we have seen by typing I, we create the instance. Okay. I is a keyboard shortcut key for taking the instance. Okay. Now I will take another instance. So again, I'm typing I. Okay.
Hello. Hello, Gauri. Are you there?
Yes, sir.
See, you are doing NAND gate, right? See,
Yes, sir.
here is where you have made one folder NAND gate name. You just
Yes.
don't need to create library multiple times. See, you can put this in that library also. That having no any folder. So you can just go to new, then cell view, right? And you can select your library which you have created earlier, right? But in this folder, no library will be saved, right? So
Yes.
first you need to create the library with the name of NAND or something like that. So just create the library name, right? Write here NAND. Don't put space. You can
Okay.
write only NAND. Yes, Ritika, for you also. You have created. Fine, very good.
Sir, apply and okay, no?
Yeah, yeah. Apply. No, not apply. Yeah, okay. Use the GPT ID. Gauri, use GPT ID. Shrutika, what are you doing? You have come. You are doing NAND gate, right? Okay, fine. Okay, just go to browse option, Shrutika. You can find it here. PMOS 1 volt and NMOS 1 volt is fine. Yes, Gauri, you have created the folder means library. Okay, wait.
Sir,
I am selecting. Wait, I am selecting. Wait. I hope
okay.
your net is slow. That's why getting
Yes,
error.
sir.
Okay, please wait. Okay, this name is I think already exists. Okay, okay, sir. Okay, see here the message is shown successfully attached, right? So now your library has been created. Now you go to the cell view, right? And in that cell view, you just select your whatever the library you created, right? It is showing here.
Yes.
Are you able to see?
Yes,
Just
sir.
type the cell name NAND. Just type the cell name NAND. Then okay. Then license okay. Now you can design here NAND gate, right? NAND gate
Okay.
consists of two PMOS and two NMOS. That two NMOS are connected in series and two PMOS are connected in parallel. Just place like that, right? For Shrutika, you also two NMOS in yes, two NMOS in series. No, two NMOS in series and two PMOS in parallel.
बोल रहे हैं ना तो मुझे लिखना पड़ता है एक बार पार्टी
Wait कर रहे थे.
नहीं वो
Hello, Chakadar sir, are you there? You are going for NAND gate, right? Okay, fine. Hello, Mohammed Ali, you are going for NAND gate. Okay. So, why are you creating multiple times library? Library is required as such. See. Rahul, are you there?
Yes, sir.
Okay, fine. Rahul, you have to practice for NAND gate as you. Please wait. See, a tool has been invoked, right? You just connect with any desk. You have connected with any desk.
Yes.
Inverter. Acha, sir is explaining you for inverter. You just try for inverter first, right? Just press the password cat 123. Press the password.
Sir, I wanted to ask that we have to connect to NMOS in series, no? So
Yeah.
it is NMOS 1V and second is also NMOS 1V. So we
Yes.
need to
Yes.
change
Yes.
the names.
Yes. No need to change. It will already get changed. See, see that you can see here NM0, NM1 it will show you, right? That is the name of the transistor. See, 1 volt is common to all, means that we are using that whole circuit comprises of 1 volt only. But the naming you can see here in this here screen, NM0 and NM1.
Yes,
That
sir.
is okay, fine.
Sir, then in add instance, we need to give different values to them.
Yeah, you see, you can change the width. That's not the issue. but let it be for the same only, whatever the width are there, let it be same only. During the parametric variation, we'll show you how to change the width and all. So let
Okay.
it be here. No need to change the name.
Okay.
Yes, yes, Rahul, are you there? Yeah, you have created the library, Rahul. Okay. So you did not go to library manager directory and all. Please wait. I'm showing you once. Go to file, new. Okay. File, new library. Then you have to type your name. Okay, library manager is there. Okay, Rahul, you do. Attached. Then press OK. Okay, library error. Okay, GPDK 90 select. No, sorry, GPDK 90 select. Okay, okay, press OK. See your library, I think here library has been created, I think. Yeah. Go to file, new, then save view. Just select your library first. Oh, no library has been created. Okay. Sir, please see once. Library is not been created.
Okay. Rahul, you just follow whatever the flow I have shown to you. You just follow that flow.
Hello, Poonam. Hello, Poonam, are you there?
Yes, sir.
Okay, fine. See, you have created the library. See, if you have created once, see, this is the last time you have created, right? This one or this one?
Yes.
Okay, fine. See,
Inverter.
okay, fine. In that library also you can design for NAND gate, but you want to create some another library also you can do. See, while creating library, you have to attach the existing technology, right? Then you have to
Yes,
select
sir.
that GPDK 90,
GPD.
right? Then only library will be created. See, now the library is created, right?
Okay, sir.
Now you can go to file, new, then save. Whatever library name you have given, let's say you have given NAND, right? So write the cell name,
Yes, sir.
the cell name also NAND. Don't put space over the cell name. Then press OK and ask for license. Yes. Wait. Now you ready to. Yeah, this is your schematic. Where you design the NAND gate. So in the NAND gate, you have to connect 4 transistors that two PMOS are in parallel and 2 NMOS are in series.
Okay, sir.
Okay, do the connection. Do it fine. Very good. Yes, Chakra, are you there?
अरे उसको दूसरा फ्लो नहीं.
अच्छा ठीक है, आप एक्सप्लेन कीजिए कौन सा फ्लो बता रहे हैं.
Sir, my PC number 7, I'm unable to connect, like I'm unable to search VDD.
Rahul, please wait. Sir will create your library. You just see the screen. Sir will create for your library. Please wait.
Sir,
Yes.
sir, I'm unable to search VDD.
Okay. Go to analog library. Who is there? Shrutika.
Sir, Gauri.
Gauri. Go to analog library. See, in this library you will not find VDD. Go to analog library. Analog component will be there in analog library. Now it is fine.
Okay.
Okay.
Yes.
To the connections. If you have any query, you can ask to me. Anybody?
Yes, sir.
Okay, fine. We want practice, more and more practice. You learn more. Very good. All are doing very good. Yes, Poonam, do the wiring connections. Select the narrow wire and do the wiring connections.
Yes, sir.
Okay, fine. Rahul, now you can continue. Sir has created the library. See, the schematic editor window is open. Now you can continue. We will guide you. Rahul, are you there?
Yes, sir.
Okay, fine. Go to the instance. See, this is an instance. Go to create instance. Click on it. Very good. Select the library. Which library you have created? GPTK90. Means we have to select the instance like PMOS and MOS. So in GPTK90 you will find. Yes. Then go to cell, or you can directly write here PMOS 1 volt, or you can go to the drop down menu. You can find it here. PMOS 1 volt. Yeah, you can take NMOS 1 volt also. Fine. Then hide this. Okay. Place it. See, this is NMOS. You can place somehow. Okay. Okay. Press escape. Okay. Fine. Go again. Select one PMOS and place just above this NMOS. Okay, fine, very good. Select first one. Okay, select it. Hide. Click on hide. Okay, just place above in proper alignment. Okay, right. Very good. Just place it here. Okay. Press escape. Done. Now do the wiring. Choose narrow wire.
Okay, Rahul, if you want to connect these two terminals, what you need to do? There is a shortcut. There is a shortcut for taking wire. That is a W on keyboard. If you put a W, one cursor will get attached to your mouse cursor. Okay. So like this way, you can one time you can click here, and then if you want to place the line floating, you need to click 2 times. Okay. Similarly, you can make the connection like suppose if I delete this connection. Sir. Okay. So if you want to make this connection between these two nodes, you just need to type W. Then this wire node will be get connected to the cursor. You just need to one time click on node, move the mouse, and then again one time click. So like this way you can click the terminals. So are you following?
Yes, sir.
You just do your on your, so I will get that you are getting that thing. I'm observing your PC. Type the W. Have you typed W on keyboard? Huh. Now, yes. If you want to move, one time click and then move. Yes. One time click and move like that way.
Sir,
Yes.
Yes.
sir, the one NMOS that I've connected, I'm unable to remove that wire, sir.
You just select that particular wire. For example, if I am selecting this wire, okay, that wire will become solid wire, okay, and press delete on your laptop.
No, sir, I've
Delete.
done that, but this small wire, I'm not able to delete it from the that X arrow on the screen and also from the delete, sir. So that's why I'm.
What is your PC number?
Sir, 7.
Sir, check PC number 7.
Yes. Where you have stuck.
Sir, this wire, sir,
See
this
this.
blue
You have
one.
to zoom it. See, you have to
Yes,
zoom
sir.
it. Zoom. Just select, then press delete button. Simple. Zoom it, select, delete. Fine.
Okay, okay. Thank you,
Okay.
sir.
Okay.
Okay, Rahul, if you want to keep wire floating, you just 2 times you need to click there. Okay. Similarly, on output side, you can
Yes, sir.
create a wire. So a one time click, and here for this floating terminal, 2 time click. Okay. So like this way, I have created this inverter design. Okay. So now for this, I need to connect the inputs and output ports. So for port, if you want to take a port, there is a shortcut P on your keyboard, P. Then this window will get open, create pin. Okay. So I want input pin. So here input pin is V, that is a inverter input. So if I hide this, I can place this pin here, V. Similarly, if you want to take a output pin, you can take a output pin. But here direction should be input or output. For an output pin, direction should be output. Output. So here I can put V out. Okay. Then I can hide this and place it here. One time click. Similarly, here you can see this VDD that will be connected to the source of PMOS, and this source of NMOSFET will be connected to the VSS. Okay, so we will require VDD and VSS input ports. So there are 3 input ports in our design: VIN, VDD, and VSS. So we will create VDD and VSS now. Again, type P on keyboard. This create pin option will open. Here select VDD. Okay. Direction should be input. Then if you hide this, one VDD pin is get attached to your cursor. Okay. And if you want to rotate this particular pin, if you want to rotate this particular pin, you just need to press R on keyboard. So it will be get rotated. Okay. One time click. If I press R, this pin will get rotated. So I am placing it here. Okay. Similarly, I have placed VDD here. Now I want to create a pin for VSS. So again P. At a time also you can create all the pins, input pins and output pins. But for you are new, so I am telling like this. Hide this and rotate. Okay. So like this way you can connect the pins to your nodes. Okay. So you connect it. So I can observe. Type P, or here also there is a shortcut, means creating pin. This is also create pin option is there, but shortcut key is also there on keyboard, P, to create a pin.
Hello, Shrutika, you are doing wrong connections. You just see NMOS, as I told you earlier, that NMOS is connected with that of ground. The substrate will be connected on ground, right? You have connected in the, so just connecting with the ground. So I'm showing you once. See, this will be connected with that, and this will connected here. Now it is fine. Just check and save. See, one warning is there. You just check it where warning is showing. See, you can zoom it. That place you will find that warning. Are you able to hear me? You just check and save. You find one warning is something like that. You can check it in the log file.
If you want to rotate the element, press R.
In the log file, you can see here in pin B it is showing warning, right? Pin B, input output is flowing. So you will go just go to the pin B. See this one, I think, yeah, this one is floating, right? So you have to do proper connection so that it will be connected or not. You have to check it once. See, no message is showing. That means your circuit is correct, means it is safe and no error will generated. You can see it here. Schematic check with completed with no error. Always check the log file. This is the log file. Whatever the activity you are doing, it will reflect in your log file, right? So you can check your log file. That means your circuit is correct. Now you go for the ADL simulations. Okay, fine. Gauri, right? Okay, fine, very good. Just connect it here. Okay, fine.
Yes, there also you can rotate it. Right click here.
Fine, fine. Please wait, Gauri. I think
Select now.
don't connect it here. Just connect it here. And one more. Now it is fine. You just put the source. Just put the source here.
Yes. By up and down key, you can move your design up and down. Keyboard up and down key.
बोल रहे Hello.
Yes, sir.
Okay, fine. You just place the source, right? VDD and ground in between them. I have asked to put a ground, right? Just place your source, right? VDD, ground, and VDC. Then check and save. Go for check and save, then you'll find. Yeah, there is no
Sir,
error.
I've given ground and VDD.
Okay, no. An extra I want. See, for source. Yeah, you have given correct. Just put the source here. Supply that you have to provide a supply voltage of like, so that circuit will give a supply voltage of 1 volt here, right? And do the, and I'm giving the supply voltage. See, you can check the log file. That is schematic check completed with no error, right? Now you can go for ADL run simulation that I have told you, like launch ADL and all. From here you can test. Okay. Or if they ask for license, press yes.
Yes.
Okay, fine. Go. Shrutika, please provide the input. Set up the stimuli. Yeah. You just provide different input, right? And for you also, see, you have to input A and B. Just make it enable and provide different value. Like, let's say first we have given like provide pulse input only. Like you just need to change the period. Like period we have already defined 100 nanosecond. One you put 100 nanosecond, another you can put 150 nanosecond, whatever you want. Just put some different value. See, first you select the pulse, right? Here you define the voltage. Whatever you want to voltage, let's start first with 1, then 0. Then just change the period accordingly. Let's wait. Okay, fine. Yeah, Shrutika, change the voltage level. You have to keep two voltage at different value. One at one, next is 0. Similarly, yeah, very good. go for period. See, first voltage you have given 1, next is 0 you have to put because it is a pulse form, right? And period 100 nanosecond, whatever you want. In the first input, if you are providing the period as 100 nanosecond, in the second input, you just change it to 150 nanosecond. Accordingly, you change the pulse width also. Put the delay time, whatever you want to do. Yeah, 10 nanosecond, 5 nanosecond, whatever you want to do. Okay, fine. Yes, what about you, Poonam? Poonam, you have connected well. See, one or two connections left that I am showing you. See, here this connection is left, right? So you have to connect this. Yeah, you have to connect this. Okay. Oh, okay, fine. No, this I think is incorrect. Poonam, let's look here. What are the connection need to do? This is the see. This is the common input you have taken. This is the common input taken. Very good.
Yes, sir.
But in the PMOS, you have to connect one VDD, right? So what you need to do is that these two PMOS will be connected together, right? And that will be connected with that of VDD here. So as I type here VDD, select place VDD here, right? Now it is good. Now see, you can see the fourth, this terminal, this terminal, this terminal, and this terminal open. So whenever you go for check and save, then it will show 4 warning. You can see 4 warning, right? 4 warning means that are open terminal. So you need to connect it. As I told you in yesterday, PMOS must be connected with that of VDD. That the substrate of that PMOS will be connected to that of VDD, and NMOS is connected to that of ground. Right? Okay.
Yes, sir.
Okay, fine. Now you can see your circuit is complete. Now I go for check and save. See, no pop-up window is open, so it means our circuit is
Yeah.
check and save complete with no error. You can see here the log file, right? Always see the log file. Whenever some error occur, you can see check your log file. There it will show the error. Now you can see the in your log file there is no error. Yes, Chandrakanta sir, I will come to
Yes.
you within a 5 minutes. Now, Vishaka, you have to do provide a signals, means provide a supply voltage here. As I suggested you last class, just provide a supply voltage here so that circuit can be operated data supply voltage. Similarly, you work VDC. Now you're able to connect all those wires, right? Okay.
Yes, sir.
See, this is the supply voltage we are providing to this whole circuit, right? And supply voltage we are providing, like let's say 1 voltage we are providing 1. Now again we will do check and save. Whenever you do the any correction, we always click on check and save. You can see your log file here. Where is your log file? Yeah, check and save with no error, right? Now go for ADL, launch ADL. Now the same process you follow. If they will ask for license, always press yes. Okay, very good. Continue. Yes, I am coming to you. Rahul, are you there? I am coming one by one. Rahul, are you there?
Yes, sir.
Okay.
Yes, sir.
Oh, yes, see, you have done the connection very well. I give you one two suggestion. See, this terminal is open. This terminal is open. Actually, it is a three terminal device, but this terminal has a substrate layer. So, as I explained in the last class, you need to connect this substrate to that of VDD. Means PMOS is always connected to that of VDD, the substrate of PMOS, and this substrate of NMOS always connected to that of ground. Here you have taken VSS, no problem. Now, what you'll do is that uh, you just go for check and save. You can see the log file here. This is the log file. In this log file, it is written the last two statement. You can see the schematic check complete with no error. Let's say some connection. Let's say if I remove some connection, then it will definitely show warning symbol. See, pop-up window will occur. See, it will reflect that this is open. Right. So we need to connect this. So this is the types of warning will show you. Please wait. Now we can save. Now it is done. See, one more thing I want to suggest here, you can given the pin as a widget, right? And we can use symbol also, and we can use symbol also. So based upon you, see, if I use symbol here, wait, if I use symbol here, that that symbol are found in analog library. Analog library, you type VDD, right? Just paste one VDD here. Again in the analog library, go to type ground, G and D. Rahul, are you Are you able to see, right?
Yes, sir.
Okay, fine, very good. See, now again I'm checking. Whenever I do the correction, I will go for check and save. Now I want supply voltage in between this circuit. So what we'll do, we will provide a supply voltage. I have just copied this VDD by using C command. Copy that VDD and copy the ground here, and I will provide one supply voltage here like VDC. In analog library only we will find VDC, where we provide a supply voltage. See, this is VDC. This means that this whole circuit is done in schematic editor window. So if you provide the supply voltage in between the VDD and the ground, then it will flows through from VDD to ground. That means circuit will operates, right? Now you can see I am providing here DC voltage as 1 volt. That means in this circuit 1 volt supply voltage has been inbuilt, right? Now again go for check and save. Now you have to do simulation is checking of, go to launch ADEL. See, ask for license. Whenever they ask for license, you press OK. Now from here you aware of that? Okay, you don't know from here how to simulate. See, from here you have to first go to stimuli, then put the input. Means you have to give the input value. See, for that input value, you have to first enable the spin, then select the function as a pulse. You want to provide a pulse input. See, they are asking for voltage 1. You can give the voltage level 1 as the 1, and next level is 0. As it is in pulse form, the highest voltage we have provided 1 and lowest voltage is 0. Period, you want to put a pulse period of 100 nano, 10 nano. Rise time you have to give something like 10 nano. I've given 10 nano. Then pulse width of 50 nano, not 50. It is, sorry, 40, because 10 and 10 will be go in the rise and fall. That's why overall is 40. See, I have enabled it. Okay, fine. Now go to analysis, choose transient, right? In the transient you have to, let's say we have to check for 5 pulses, as we have given the period of 100 nano. So for checking 5 pulses we provide for 500 nano. Apply. Okay, this is the transient analysis. Now last point, what you want to see the output. Go to output to be plotted, select on design. It will automatically come to your design window. Now you select whichever you want. I want to see the graph between input with that of output. I will select these two. The color has been changed. You can see again, come to the ADL window here. You can see that this output has been selected, and nothing, you have to go to run option here, or you can go from here also, simulation netlist and run. You will wait, you will find your output. Please wait, it is running, taking time. Yeah, this is the output. In this output you can verify that this is your input. It no problem. See, then when input is 0, we are getting output as a 1. That means it is performing like inverter, right? Rahul, have you understood? Now one more thing I want to say, that whatever we have given the,
Yes, sir.
whatever we given here, we need not to give again and again. What we do is that we go for session, save state. Whatever the state we have given here, we just save the state. That means whenever we close this, again go to ADL, then you want to load your session, you can go from here, load state, then press OK, all the station will be loaded. Then only you need to press run button, that is netlist and run, then you will find the output. So after closing this window, you just need to save the state, right? Okay, I have done one. You just try for another one, that is NAND gate. You design for NAND gate, right? Go for that.
Sir,
Yes, who is
sir,
there?
I have given the values for A and B. Sir, PC
Okay,
number 7.
okay, BC number 7, fine. Yes, you have given the value of A and B. Have you enabled? I have to check it. Please wait. Stimuli. Okay. Okay, you have given. See, rise time, fall time you have to give, right? And pulse width also you have to give. See, without rise time, fall time, pulse width, it will not run, I think. See, put some rise time and 10 nanosecond I have put in. Again 10 nanosecond. Pulse width you have to see. If it always the pulse width is the half of the period. You have given period as 100, then the pulse width will be 50. But 10 in the rise time it will take 10 nanoseconds the rise and 10 nanoseconds the fall. That means the average of these two will be 10 only. So we will subtract 50 minus 10. That will 40 nanosecond. Right? Just you need to half of that and subtract any one, either rise or fall.
Sir,
So we'll
like
get
a
it.
delay time minus rise time, no, sir?
No, not
Like
delay time.
40.
See, like that period, just half the period, that is 50 nanosecond. Then you have to take the average of these two, that is 10 and 10. Average of these two will be again 10 only. So the 10 will be included in the rise and fall. So the effective width will be only 40 nanosecond only, right?
Okay, sir.
Okay, fine. See, one I have put it, another also I have to check again. One is okay. And see, as I told you, don't put the same period, because when you put the same period, you cannot able to differentiate the output, right? So you need to change little bit. Let's say I am giving 160 nanosecond. Delay whatever you want, you can put. Rise time, let's say I'm giving rise time as a 10 nanosecond. It's all upon you, whatever you want the rise time, right? Now you
Yes.
just half it. 60 half is how much? 80. 80 minus 10
80.
is how much? 80 minus 10,
7.
70. Just put 70.
Okay.
Right. Now it is okay. Now you have to go to analysis, choose. You have to want to see the transient answer, right? See, as we have given the highest period of 160 nanoseconds, we want to see the 5
Hmm.
pulse. You just need to multiply 160 into 5. Let's say 800 nanoseconds. It's all depend upon you. You
800.
want to put, you want to put 16 nanoseconds, it will show 10 pulse, right? Select moderate, then apply OK. Yes, Gauri, apply OK. Okay, fine. See, the transient is showing here. Fine. Now go to the output. You want to plot, right? So go to the output. To be plotted, select on design. Yes, Sutika, what about you? Uh, please wait, Sutika. I'm checking your first input, then only you can run. Please wait. Stimuli, okay, fine. See, one you have on and second is off. You can see here. Sutika, are you there? See,
Yes, sir.
you have to enable both, right? As a suggested, see, you are providing two inputs. You have to enable both one by one. See, voltage level you can put any as of your wish. In the first one, you have taken the voltage one as a one, right? Now I want to take voltage two as a one, and voltage one as zero. Just swap it, right? See, the previous one you have put it the period as 100, 10, 10, 45. In the second one, just change the pulse a little bit, because if you put the same pulse, what will happen is that you cannot differentiate the output. What you need to do is that you just put the period, let's change it for 160 nanosecond. Let's change it for 160 nanosecond. Delay time, whatever you want, you can put. See, the rise time, whatever you want, you can put. But the calculation of this pulse width, you have to be very much careful. See, as I told you that the period, just for the pulse width, you just half the period. This is, you have taken 160, you have just half it, 80, right? And take the average and subtract the average of these two, rise and delay. The average of rise and delay is 10 only. So 160 half is 80. 80 minus 10 is 70. 70N. See how I have put it. Have you understood what we have done? We have just half the period and subtract the average of this rise and fall, right? Because the effective pulse width will be only 70, because rest 10 and rest 10 will be used in the rise time and fall time, and right. Now we'll apply. Okay, now this time you can see, okay, you have selected the output also. Now you can run. I hope it will be, yes, you can see the output. You can see the output. See, this glitch is come due to the delay, because due to the delay, you can see from this pulse it is following, it is obeying the law, right? Whenever it is 1 1, it is showing 0. That means your output is correct. Yes, about Gauri, have you checked the output? Okay, you have not checked the output. See, go to output, to be plotted,
Sir,
select
I've done it.
okay, no. Please wait, please wait. If you have done, it will showing here, right? You have to select like this. This color will change. See, that means it is selected. A, B,
Okay.
C, color change, then Y. Now it is done. Now again go to ADL. See, this will be loaded here.
Okay.
Earlier it is not loaded here, right? Now it is loaded.
Oh, yes.
Now you go for netlist and run. That means this green button you can click anywhere. This green button is also netlist and run only. Click on that. Click on that. Very good. Now you can see what. See. See, some error it is showing. I will connect it. This is not the correct output because the highest peak is 900 something and lowest peak is 450. It must be from 0 to 1. It must be from 0 to 1. So I need to check it once. Please wait. I hope you have done some incorrect. I have to check it once. Setup, stimuli. Okay. Okay. Have you provided here DC voltage 1? Okay, fine. Okay, this one is your VDC. What is the mistake you have done? You can see. This is your pull-up circuit, right? And this is your pull-down circuit. What you have done,
Yes.
here you have to place PMOS. You have placed here NMOS. And here you have to place NMOS. You have placed PMOS, right? So you have to be very much careful. See PM0, PM1, you can see it, right? You just need to, what you need to do is that, wait. You just need to delete this. You need to delete this. Just paste, just put here PMOS, these two place PMOS and these two plus NMOS. Then your circuit will be correct. Don't delete the wire, just press PMOS and NMOS. And just after that, just click on check and save.
Okay, sir.
Okay, Poonam, what are you doing?
Sir, PC number 3.
Okay, I'm going one by one. Yes. Okay,
Yes, sir.
what you are doing for NAND gate? Very good. Okay, carry on. Yeah, yes, Rahul, you're correct. PC number 3. Okay, PC number 3 is Mohammed. Yeah, right. Yes, Mohammed, what difficulty you are facing? See, I can check it here. You have not
Okay, sir.
given the analysis. You can choose analysis. You have to select the analysis. What analysis you want to see, right?
Okay, transient.
Transient analysis. Without selecting an analysis, you cannot plot, right? I have to
Yes, sir.
check it for stimuli also, right? See, one you
Yes.
have on, second is off. You can see here.
Yes,
See,
sir.
we have provided two input, both either parallelly we have to select on, right? In the
Yes, sir.
first you have selected on, very good. And you have see,
Second.
always see, one more thing, always
Yes,
give
sir.
the unit 40N. If you
Yes, sir.
don't put the unit here, it will automatically take the second value. But you don't want in second, you want in nanosecond,
Yes,
right?
sir. Yes.
So
Yes, sir.
one more thing I want to suggest to you that, see here you have given the period of 15 nanosecond, right? Just give it 100. You can give it 50 also. I will explain you. Let's
Okay,
say we
sir.
have given 100. Let's say we have given 100. Delay time 10, rise time 10, fall time 10. See, always period is half of that of pulse width, right? You have
Yes, sir.
given period is 100 nanosecond. You have to just make it half first. That a half of that 100 is 50, right?
50,
And
right?
you have to take the average of these two. Average of these two will be again 10 only. Means
10.
rise time, fall time is 10. So now
Yes, sir.
subtract 50 minus 10. How much?
40.
40. Now, see, one we have defined. Another one we will select, we will put enabled. You have to define this one also. Now, what we'll do is that voltage level 1. What you will do, voltage level 1, see, earlier we have given voltage 1 is equal to 0, right?
Yes, sir.
We
Yes,
need
sir.
to change it. We can swap the voltage, right? We have
Okay,
given
sir.
voltage 2 as a 1 and this one as 0, right? Now we'll provide the period. Period, see, don't put 100 nanosecond because if you provide the same period, then it will, the output, you cannot differentiate the output. You need to
Right,
change
sir.
the period. We have given 160 nanosecond, let's say, right? Whatever
Yes, sir.
you want, you can put. I have given 160 nanosecond. Rise time, fall time, I keep same. Delay also same. Now you should tell me how much I put the pulse width.
150, sir.
No, why 150? Just
Sorry,
divide.
sorry.
First divide 2. Yeah.
Yes.
Yeah. Tell me how much.
So 70.
Very good. 70. Now it is okay. Now you have understood well. Very good. Now it is all okay. Now you see one more thing I want to tell you. These are the output you have selected
Sir,
fine,
I'm
but
getting
okay.
error.
Okay. Wait, I am coming one by one. Yes, your
Okay,
output
sir.
has came, but it is deteriorated. Mohammed, you just check it. I hope you
Yes,
have
sir.
not provided supply voltage. I hope. I have to check it once. You have provided supply voltage Z. You have not given the supply voltage. Without supply voltage, circuit will not run. You have to provide the supply voltage here. Whenever you do any correction in the schematic, just need to check and save, right?
Check it. Yes, sir.
And again, you can go run from here also or go from AD also. It will go. Okay. Okay, please respond. Chakadar sir. Wait, Poonam, I am coming to you. Yes, Chakadar sir, are you there?
Yes, sir.
Yes, Poonam, please wait. I am coming to back to you. यहाँ पे लिखिएगा हाँ and it is देखिएगा. Okay, fine. Your output is correct, I think. Hello.
Yes, sir.
See,
Yes, sir.
yeah, output is correct. If you see, this glitch is occurred because at the same time this two has occurred, right? That's why this glitch has been occurred. You can change the
Delay.
pulse width, you delay and pulse width, you will find. Yes, Poonam,
Okay.
what are you? Yeah, I have to check it once. Okay, VDC you have connected. Very good. Okay, all are fine, Poonam. You just go to ADL window. What you have done, just show me. Okay. Okay, I'm going to your ADL window. Okay. Go to session, setup stimuli. Please wait. Poonam, you see here. You have given all thing fine, very good. But you have not enabled. Whenever you not enable, it will not showing on here. See, it is off, right? You have to enable it first. Then apply.
Okay, sir.
Then it will show on. Now you see on, right? In the same way, you have to this enabled also, right? And you have to select pulse. You can see it first here. We see in this first that is the input B. You have given voltage 1 as a 1 and voltage 2 as 0. We need to swap this. We need to swap this on next. What we'll do is that. Sorry. What we'll do is that. See, earlier we were taking voltage 1 as a 1. You can see it here. You just provide voltage 2 as a 1. Right, fine. You just change the earlier we are taking this 160, you just provide it 100 nanosecond, whatever you want. Just put the different period so that we can differentiate the output. Now, how we'll define the pulse width? You just listen to me, Poonam. You just half the period. You just half the period. You have given the period as 100. Just half the period, that is 50, right? And you take the average of these two. The average of these two will be again 10. You just subtract the average of these two. That is 50 minus 10. How much you are getting? 40. Fine. You just provided 40. Now you can see both are enabled. Both are enabled means on. It is showing on. That means input has been provided, right? See, again, one thing I want to tell, in this transient, you have not provided the time. You have to provide the time. If right in n, if you don't provide here that unit, it will automatically take second. It will take in second, it will take long time to run, right? So just provide the stop time as a nanosecond. I have put it here n, right? You can go for second also, but it will take larger time. So I've given you 800 n. Moderate, apply, then okay. Now it is showing, right? Now you can go for run directly from here, this tab. I have clicked on run. Please wait. It is loading. Yeah, your output is fine. You can cross check the output. See, this glitch has occurred due to the delay. Let's say I want to put it A as a first. I'm just dragging it and dropping B as a second. Now you can check it. This 0 is occurring whenever these two pulses are 1. Whenever these two pulses are 1, the 0 will occur. Rest all 1. This is the glitch is shown due to the delay between these two pulses. After that, your output is following. You can check the truth table. It is verifying or not. Right? Okay, all of you have done. Very good. Okay, what
Yes,
about
sir.
you? Please wait. See the extra graph you may delete, select and delete. Need to intermediate are not required. Okay, fine. All of you have done. Very good. Gauri has done. Sutika done. Poonam done. Okay. Okay. Hello, Chagadda sir, are you there? Chicken sir, you take on, carry on. Someone please respond. Is नहीं करना है ना? हाँ. इससे पूछे किसका हुआ? कहाँ के? बच्चे को दे सर को ले लेते हैं लाइन पे. नहीं आने में. कॉल भी इनका. कॉल करो. हाँ, कॉल करिए. अरे वो क्या क्लास
Hello, sir.
Our person is there to accept you. Okay, no problem. No problem, sir. No problem, sir. 12:30 you will. 12:30 you will remain there. Okay, sir. Okay, sir. Just send the request. Sir will accept. Okay, fine, sir.
Okay, all of you, good morning once. Okay, so are you there? You just raise your hand so that I can understand.
Yes, sir.
Yes, sir.
Uh-huh. Just raise your hand.
Yes, sir.
Yes. So all will be in right flow, right? So now yesterday you have created the schematic for this inverter, okay? So what you need to do now, you just need to close your NAND gate design and go to the library manager, okay?
Save your state.
First close the NAND gate design now. स्टार्ट करो या नहीं
डीएल में स्टेट सेव करना होगा.
Just close the schematic editor only, okay? Don't close the Cadence Virtuoso. Just close the schematic editor only. This library manager should be there, okay? So all of you just close your, don't close the Cadence Virtuoso. So whatever screen you are seeing on my,
तेच म्हणणार होतो यांचा कॉल येतो मी थांबलो शेखर सर
okay. Is this screen visible now, library manager?
Yes, sir.
So is this screen visible now, library manager? You just close those who have created the inverter design, keep as it is. And yesterday you have created the inverter, other fellows. Okay.
Yes, sir.
So you just close 2-input NAND gate. Row the PC number. PC number 78. Close your NAND gate design. Don't close the Cadence Virtuoso. Okay, library manager should be open there. Okay. So library manager should be open there. Now, Open the library manager. PC number 7 and 8. Maybe library manager window is at the top, bottom. You may see. Am I audible to you?
Yes, sir. You
Yes.
are audible.
Yeah, PC number 7 and 8. On the bottom, there will be the library manager window. You just see. Otherwise, you go to tools and from there, library manager. Okay. You maximize the library manager. So your screen should be like this only.
Yes, sir. Done.
Good. Now, yesterday, the library you have created for the inverter, go to that library. For example, I am created Chetan Day2 design. Okay, so I have selected that library. So after selecting that library, you may have seen in library manager only. In library manager only, you need to select. Don't cancel it then. Cancel. Yes. Go to library manager. Okay. Now, so all of you are following this. So I have selected my library here, Chetan Day2 design. Okay. Listen it carefully. Chetan Day2 design, and in that my cell is inverter underscore plane. So click on that cell, whatever the cell for your inverter is there. Let me tell you, in which folder have you created the inverter? You have created the inverter in other folder?
Yes,
Sir,
sir. We have created in different
JDPK
folders, sir.
29.
No. Other folder I am asking.
Yes, sir. Other folders, sir. Separate folders.
So in that folder you go and from there you open the
Open the virtuoso.
Cadence Virtuoso.
Yes, yes. Okay, sir.
I thought that in same folder. Okay.
Sir, I've made a folder like what you have told yesterday here.
Yeah. So in that folder, inverter design was there.
Yes, sir.
Okay. So you just here you have selected this cell inverter. You go to the schematic this part and double click here. So schematic window will get open. Right?
Yes.
Now this inverter schematic is get open, right? So we will wait for other fellows to pace with our speed. Just a minute.
हाँ ठीक है फाइन इसको यूज कर लेते हैं
Okay, now this inverter design is open. Whatever the DC supply you have taken and whatever the ground terminal you have taken, just remove it. Okay, just keep the pins. So your schematic should be look like this. For example, if there is some DC source, right, or if there is some ground, right, so how to delete it? Just go there and delete it, right? So delete your ground and other things, VDC and grounds. Okay, yes, delete it. Yes, you have done right, Mohammed. I will tell you. Create the pins for VDD and VSS. Those should be input pins. Yes. PC number. PC 8 है क्या? PC number 8 you have done right. Now create a pin for VDD and VSS. The PC number Rahul, you remove the VDD and ground from the that diagram, and instead of that keep VDD and VSS pins. Okay. To take a pin shortcut is P. And those VDD and VSS should be the input pins. Okay, those are the inputs. If you want to rotate that particular, press R. If you want to rotate that particular pin, press R. R.
Sir, my schematic is not opened, sir. PC number 7.
Yes. On the bottom there may be the schematic open. Schematic window may be open. Okay, I will just tell you how to create the pins. So I'm removing the VDD and VSS. Okay.
Yes,
I'm
sir.
pressing the P button on keyboard to create the pins. So here I am placing VDD. Then after giving the space, then VSS. Okay. So these two are the input pins. So I am hiding this. So here you can see for your mouse, the VDD get attached. Now, if you want to rotate this pin, you just need to press R. So if you press R, this will be get rotated. So I'm pressing the R. Okay. So I will place like this here. Similarly, after that VSS also we have taken. So VS after placing the VDD, VSS is connected to the cursor, right?
Yes.
So then place again, do the R and place it like this. So in this way you can create the pins. Now if you want to move any element, what you can do, suppose I want to move this element, I will select this element. So whenever you select that element, okay, one solid square will be come around that element. Okay, so if I move that, so it will move like this, right? Now wire is
Yes.
connected to that. Okay, so Mohammed has done this, Rahul has done. उसका नाम क्या है? PC PC5 has done that, right? Good. So I'm waiting for PC number 7 and 8. If you want to take a pin, press P on keyboard. लगा दिया? To rotate R. R should be type on keyboard. Yes.
Yes, Kunal, you have done. Very good. Okay, all of you have done, sir.
Sir, how to track this VDD over here, sir?
Suppose if I take a pin here, P pin, okay, VR. If I place it here, if I want to move this pin, so what I can do, I can just click on that. So square solid will come across that, right? So then I will move that element to this point. Okay. Now, if you want to rotate this, you can right click on that. Okay. Otherwise, you can press R, and then for your cursor, there will be a symbol like this. You just click on that, so that will be get rotated. Similarly, if you want to rotate it like this, again R, rotate. Again R, rotate.
Yes, you tried.
Got it?
Yes, sir, done.
So all of you are with this design correct, right? So now we need to check and save this schematic. Okay. we need to check and save this schematic. So if I check and save, so in the log window, you can see no errors are there for this design. Do check and save for this. So how to do the check and save? So on the top one, there is a check and save option. All the windows on the bottom side, you can see all the windows on the bottom side. If you want to open the Virtuoso schematic editor, that is here. Okay, have you done it? So anyone got errors? Anyone got some warnings or error?
No, sir.
So we can proceed, right? So why we have created this, why we have connected this pin to this particular inverter. So we need to create a symbol for this inverter. So for example, if you want to use this inverter in some big design, like very complex circuitry, you can directly take this inverter and place it in your design. Okay. Another advantage is that if you want to create a chip, so we are creating a chip for inverter here, right? So for that purpose, we have given the schematic entry. Okay. So if I want to create a chip for particular this schematic, so in this my inverter chip, there are 3 input pins: VIN, VSS and VDD, and 1 output pin, right? So after fabrication of that chip, only after the fabrication of the chip, we connect the input and output elements like input source, VDC, ground, right? Okay, when you use any chip, you connect external sources, power sources, right? So while creating the design, we only create the schematic. Okay, now after creation of this design, we need to verify that it is working like an inverter gate or not, right? So for that purpose, we need to test this circuit, okay, before going to the layout extraction. So for that purpose, first we create the symbol for this. So to create the symbol, uh, on the topmost toolbar, there is a create option. So here you can see the create, okay. So create option is there. I have click here, create. All of you, go to the create. Rahul, go to the create. Yes. Now in this create, uh, you can go to the cell view, create cell view. Yes. Now go to the cell view, then from cell view. Okay. After clicking on from cell view, first option from cell view. Okay. This window will get open. So all of you are here now. Yes, Rahul, click on that from cell view. Have you click on that, Rahul? Yes, yes. Now this window is get open. Now here you can see in this window, the library name is whatever the library you have created. Okay. So in my case, I have created the library Chetan underscore day2, right? In that library, there is one cell. That cell we have created. For example, you have created the cell inverter. In my case, I have created the cell inverter underscore plane. Okay. Now, view of that particular cell is a symbol. Here you can see to view name symbol. From schematic view, we are creating a symbol view. So all of you just check this. To view name should be the symbol. Okay. So this is the step for creating a symbol. So if I click OK, here, new window will get open. Symbol generation option. Okay. Symbol generation option window will get open. Now I want to create a symbol like this. I will draw in OneNote and show you that. I will tell. Okay, I will just open OneNote and how to create a symbol, means which kind of symbol we need to create. So is this OneNote is visible to you?
Yes, sir.
Yes, sir.
Now this is like an inverter symbol, right? Okay, so this is your input, this is your output, this is your VDD, and this is your VSS, right? So there are 3 input pins, 1, 2, and 3, and 1 output pin, that is 4. Okay, so we need to create a symbol like this, right? So here you can see in the symbol generation option, they are asking for which are the left pins, which are the right pins, which are the top pins, and which are the bottom pins of the symbol. So if you observe this symbol, the top pin is what? VDD. Bottom pin is what? VSS, right? Left pin is what? VIN. Right pin is what? Vout. Okay. So we just need to adjust those things. So here you can see the left pin is VIN. So I will just select this VDD. Okay. First right pin is Vout is clear. Okay. That is right pin. If I want to put the topmost pin is VDD, right? So I will select this VDD, Control X, just Control Z. Okay, do the proper Control X. Okay, only select that part. Control X, select VDD only. Select the VDD from the top part. Control Z you can do if you have mistakenly disconnected. Control Z option is also there. Okay, now I will paste that VDD here, top pin, on the top pin. Okay, so I have placed like that. Now VSS pin is bottom pin, so I will select the VSS pin. Okay, Control X, and on the bottom pin section I will paste that VSS pin. Okay, so now you properly just remove the pastes and properly make these symbols. So have you done this? Mohammed has done, Rahul
Yes.
has done, that PC number 5 has done. Okay, all of you are done, right? Okay, so after doing this, just click OK. Just click OK. Rahul, click OK. Okay, new window will open. Whatever you are seeing on my. Okay, one fellow is remained. You just. So now you can maximize this window and you can move this symbol also. For example, if you want to move the design, you can use up and down arrows, left and right arrows. Okay, on your keyboard, up and down, right and left is there. Okay, very slightly. Okay. Okay, now maximize your screen. Now here you can see the default symbol they have given here, and 4 pins are there: VIN, VDD, VSS, and Vout. Okay, so I want to create a like that rectangular kind of shape now. So what I will do, I want to delete this rectangle. Okay, so I will. You just need to click there inside that rectangular box. Inside the rectangular box, observe my screen. Don't select wrong rectangles, okay? Otherwise, other part will be get. You just if you want to confirm that that particular element is get selected, white solid line will come across that. I think PC number 7 is lagging. You just click here. Click inside the square. Click inside the square. Sir. Let her do. Okay. Now you selected that. Now you can press a delete button on your desktop. Yes. Yes, good. So you have deleted that rectangle. Now I want to make a triangle, right? So here you can see create line option is there. Go to the create line, Mohammed. Yes. Click create line, and just like you make a wire connection in your schematic. So one time I'm clicking here. So one time I have clicked. Now I'm moving my mouse. Okay, I'm moving my mouse. Okay, so just to make sure that one time you click and move your mouse. One time you click and move your mouse. Yes, good. Mohammed, good. Yes, Rahul, one time you click and just move your mouse. Okay. Yes, now you are here. Now, if I want to take a turn, one time click and then make a turn. Good. Make a short, Mohammed, because we need to put one bubble also there, right? Make a short one. Yes. Yes, more short. Yes. Just like I have maintained some distance in between, okay? So, yeah. So, if you want to turn, just click here and okay. So, like this way, you need to create. Rahul has not kept the space there because we need to space bubble. Okay, PC number 8. हाँ, अरे यार बबल के लिए स्पेस ही नहीं दिया आपने. ठीक है, चल. Now, if you want to create a bubble, create on this circle, create circle. Here you can see. Create circle. Click on that. Now, one time you click outside this. One time you click. So as you move this cursor, size of this circle get varied as you move your mouse. Okay. So just make it very small. Okay, don't make it very large. PC number 5. Again, I will show you. Okay. So here there is a circle option. Create circle on the topmost. Yeah. Here, Rahul. Here, the topmost window. Here, topmost toolbar. Rahul. Rahul, if you want to delete any, just a minute.
Sir, actually, my rectangle is got deleted.
Hello.
Sir, not able to select the circle.
Problem is there.
Yeah, I got disconnected. Okay. Now you are able to see my screen.
PC number 4.
Am I audible to you?
Yes, sir, you are audible and your screen is also visible.
Okay, thank you. Okay, Rahul, what you do if you want to delete that triangle now, go inside that triangle and click. Is he listening or not?
Yes, sir, I'm listening. Sir, problem is not that, sir. Problem is, sir, my outside rectangle is got deleted, sir.
Sir, don't select the outer. You undo that. Here you can see the undo option. This.
You for
You can do it. But for mine, it is showing clearly. Have you connected to your AnyDesk properly? Or there is some lag?
Rectangle is there, Rahul. Rectangle is there.
Client, sir, client offline दिखा रहा है Autodesk में.
No, rectangle is there, no problem. We have done the undo, so rectangle is there. Just need to correct it again. The triangle.
Symbol है बच्चों के.
It is showing that client is offline.
Client is offline.
Desk
Please
is
wait.
not offline. Desk is not available.
Check it once. Please wait.
Sir, mine also have got disconnected. PC number 7.
What will happen? Yes. What will happen? That net is get disconnected. We are trying to once again.
असं सिलेक्ट करून डिलीट करायचं.
Try once again to enter into the desk.
नाही ते नका तुम्हाला काही नाही करायचं.
All of you try to
Okay.
connect NDS again because we have internet problem is here. Try to enter the NDS again. Write the password Cadence 123.
PC number 7. Have you connected?
No, sir,
Okay,
not yet.
Rahul, have you connected?
No, sir.
Are you try to connect?
Rahul, you connect from your side. I think it is NDS is open. Yeah, this session is going on. Please check it once. Sir, I'm okay. Put your correct again. Those who
Sir,
are there-
it's showing
yes.
client is offline, sir.
Client is offline. Please wait. We have to check it once. Client is offline. Net check कीजिए. Please wait for all of you. Please wait. Please wait. We will check.
Yes, sir.
We will check the net connections. No. Check it for this system, sir. This system, check it for once. And this system also. Net is offline. Is showing something like that. Yes. Just log in again, sir.
Okay.
Mohammed, are you there?
Yes, sir, I'm here. I'm not able to connect.
Not able to connect. See, in college we are having internet problem. Please wait. We are solving it out. We are again logging into. That's why it may be showing that some. Okay, one is connected. Fine. Gauri is connected. So check it once here. Gauri, you are connected, right? Sutika, check. Sutika, are you there? Okay, you are connected, Sutika.
Sir, I'm still popping up the message that connecting, like
Connecting.
connection in progress. Please wait.
Okay, connected interface. Please wait. Okay. I'm checking for you. Please wait. Because
Network timeout, sir.
okay, network time. You can disconnect and connect. I'm disconnecting. Connect it again. I have disconnected. Okay, disconnected. Disconnected the NDS. They will connect again. Go to the NDS. Disconnect it. Okay. We have disconnected from here. NDS. You just need to connect it again. All of you, please. For Rahul, Poonam, and Srutika, just need to connect it. Okay, please connect it again. We have disconnected the session so that you can connect it again. Yes, for you also. Yeah, Mohammed, please connect it again. If
Yes,
they
sir.
will ask for, yeah, if they will ask for the password, give it Cadence 123. System password is also that same one only, and Anita's password is also same. Yes, Rutika, you
Sir,
try.
mine,
Yes,
sir, it is still offline, sir.
still offline showing. Okay, okay. Check it, sir. Offline it is showing.
Same
For you,
problem is
Poonam,
also.
right? For you.
Yes, sir.
Okay. So check it the
The
internet
same
connection.
problem occurring with me, sir.
Okay, okay. Wait. We are logging in and logging out. Okay, please wait for 1 minute only. Log out करा, login करा. Yes, for Shrutika, you are also not connected, right? We are testing for that. Please wait for hold for 1 minute only. बीच में इंटरनेट फ्लक्चुएट हुआ ना तो सबका डिस्कनेक्ट हो गया. Poonam, now you try to connect it again. We have logged in for you for your system. Mohammed, for you also, please logged in again. We have logged out and logged in again. That's why maybe the reason. So please check it once. Rahul also, and Sutika, we are doing for you. Yes, Poonam, you try. We have time. Don't be panic. We will do. Yeah, just try it. Okay, Sutika, you also try. Any error?
Sir, this desk is not available.
Okay, this
Yes,
disk
sir.
is
Same problem, sir.
okay. We have to check it
Sir,
for
trying to see.
this is not available.
Okay, which PC?
Sir, 5 number.
PC number 5. Okay. So have you entered the desk ID as a 923320369?
Yes, sir.
Okay. So let me check. अरे कल तो चल रहा था ना. Now you PC number 5. Now you try to join.
Okay, sir. Sir, still not available.
Is not available. Okay, we will try to connect. Okay. No, but one
Sir, is the PC7 connected over there, sir? Because I'm not getting connected. My network timeout is coming.
बघा बरं काय. Okay, all of you do one thing.
Yes,
Okay.
sir.
Close your any desk and again launch it. All of you close your any desk and again launch it. Okay. Okay, PC number 5.
Yes, sir.
So have you launched it again and again try to connect it?
Sir, doing it, sir.
Okay, do.
Hello, sir.
Yes.
Still we are getting, sir, connection timeout.
Okay.
Yes, sir. The same message is popping.
कौन सा भी स्लीप मोड में जाने मत दो है क्या नहीं ओके मोहम्मद यू ट्राई अगेन जस्ट ट्राई अगेन similarly Rahul and Pooja Poonam also
Sir, I am getting the desk is not available.
which PC
Offline, sir. 5, sir.
what is not available
The same message it is showing, sir. Client offline.
Yes, sir.
पूनम
Yes,
हॅलो
sir.
मी पवार सर बोलतोय तो 92332036 तो ऍड्रेस टाक ना रिमोट डेस्कच्या तिथं आणि त्याला कनेक्ट कर
काय, sir?
ती ब्लँक विंडो आहे ना खाली रिमोट डेस्क लिहिलंय तिथं तो वरचा ऍड्रेस टाक 9233203669
Sir, टाकलंय, sir.
आणि आता कनेक्ट म्हण ना
सर ते हा सर आलं सर कनेक्टिंग पण ते परत ऑफलाईन दाखवते सर
offline जाते का? Have you connected your internet connection
येस सर
क्लोज करा मला
Yes, sir. I have connected, sir. PC number 7.
What changes have you done? PC number 7.
Sir, PC number 3 also got connected, sir.
Good, good. ठीक है. Rahul, PC number 4. Is he there? Poonam, try to connect it.
Yes, sir.
Try to connect.
Yes, sir. Yes.
Then Gauri is connected. This one, Mohammed is connected. Okay. Now you try to connect it again. Are you here? Yes, PC number 8, do connect. Accept this. Accept. Oh. Who are there in meeting? Arvind Rahul is the meeting. Rahul, Gauri is there, Poonam is there, Rahul is there. Ask for Rahul. Rahul, do connect. Please connect, Rahul.
Are you there, Rahul? ठीक है, so we can start. So Mohammed has connected, Poonam and Gauri has connected. Okay, Rahul is not responding. Kritika has left the meeting. So we can start this. Okay, now you have created this symbol. Okay, and now okay. Okay, so I will take one square here, circle here, and just listen. Poonam, you have drawn very big circle, no issue. Okay. So one time I will click here, and just I will move my mouse to change its size. And if I found appropriate size, I will just again click it. Okay. So if you want to come out of this mode, press escape, then select your circle. Okay. When any element is get selected, one solid line will get around it. So I will just move that solid line and will place it here. Okay. So in this way,
Yes, sir.
I have created the symbol for inverter. If I have to give the name to this, okay, so just double click on that and give the name INV. Okay. So I'm giving the name inverter. Whatever you want to like, you can give. But don't repeat the names like a library name, cell names. Okay. Invert. whatever the name you can do, you can. Okay. So after doing this, again you need to do the check and save. Okay, the PC number 8, PC number 7. So if you want to move that square, just click on that. If you want to move that circle, just click on that circle and just move it. Okay, ठीक है. Now good. Now again check and save your symbol.
Sir, the circle size is big, no, sir, for mine.
No issue, no issue. That is only symbol, no problem.
Okay.
That is only symbol. Okay.
Yes, sir.
Now, after doing all this, again check and save. The uppermost option, check and save. So, do you got any errors? No? ठीक है then. You can proceed. Again, open that schematic editor, right? Now, go to the library manager. On the bottom side, there will be the library manager, right? Library manager. Now, in the library manager, you can see for your cell, two views are created. One view is schematic, other view is symbol. Okay? One view is schematic, other view is symbol. So all of you got this symbol, got these two views. Okay, Mohammed got the view. Poonam, you just go to the library manager. Have you check and save?
No, sir.
Have you done the check and save?
No, sir. It is showing connection in progress.
Okay. ठीक है. So have you connected now?
No, sir.
Okay. Sir, accept कीजिए request उसकी. Now you are connected, Poonam.
Sir, I think net issue at my side.
Okay, okay. ठीक है, so you again try to connect it. Okay, sir will help you after connection. So we will move with our design. So two fellows are listening, I
Yes,
think.
sir.
So one schematic is get created and one symbol view is get created. Now if you go to the symbol, okay, now make sure that your file is always saved. If your file is not saved, so here that will show the star. Okay, make sure that your file is always saved. Now you can close this symbol window. You can close this symbol window, right? Now here the schematic window is also there. The schematic window, you can close that also, right? And go to the library manager. Close the symbol window and schematic window. Now go to the library manager. Now we have created our schematic. Now we need to create a test bench file, means to apply the sources, input
Sir,
sources.
once how to close the schematic and symbol window.
Okay, at this side maybe your schematic editor will be there. Okay, if that window will get open, just click on that. So I will again open the schematic editor. So now here you can see the schematic editor is opened, right? You just close this.
Okay.
And go to the library manager. Okay. So now we have created this schematic. Okay, we have created this chip. So before going into the layout design, we need to do the functional simulation of that. Okay, functional simulation. So what is mean by this? We apply some input source to this inverter. and we check our output. Okay. Again, we apply different analysis like delay. Yesterday you have seen those analysis, right? So those analysis we apply to this diagram, this symbol. Okay. So for that particular checking, for that particular functional simulation, we need to create one file. Okay. We need to again create one cell, test bench cell. Okay. So for that purpose, go to file and make sure that when you create new cell, your libraries get selected. Okay, whatever the library, that library is having inverter plane, that is get selected. Okay, in that library only we need to create our new test bench cell. Okay, so go to file, new, and cell view. Right, new file is ready. Click on that pop-up. Now in this cell name you give inverter underscore TB, means test bench. Okay, so view should be schematic in that, type should be schematic. Oh, all those things are, you just check that. Okay, just a minute. Now you have created this schematical. Okay, so click OK here. One window will get open like a schematic editor. Just a minute. Okay, now just a minute. I am connecting other fellow. I am just telling her. Okay, Poonam, have you created? Now you are connected now. ठीक है.
Yes, sir. Sir, I'm on schematic diagram.
Schematic or symbol diagram? Symbol diagram.
Yes, symbol diagram, sir.
Yes. Make check and save it. Check and save it. Check for is there any error? No error is there? Yes. Now close this symbol window. Symbol window. Yes. Now go to the library manager. On the bottom there will be the library manager window open. Yes, good. Select that library manager. Yes. Now in that you can see for your particular cell, the one view is get created, symbol view. Now there are two views, symbol and schematic, right? So two views are created. Yes, now your symbol for inverter is get created. Okay. Now we need to create one test bench file. Make sure that whatever the library you have created, that gets selected. If library gets selected means there is a background square around it, means it darkens, right? That name is darken. Okay. Now go to file. Poonam, I'm giving this instruction to you. File, yes. New cell view. Okay. Now pop-up is occurred. Click on that pop-up. Or on the bottom one there is window. Okay. Yes. Click there. Now inverter, what is the name there? Cell name?
Sir, inverter.
INV something. Underscore TB. You just put underscore TB after that. So that will be properly. Okay.
TB.
TB, test bench. Okay. Now click OK. Yes. Now the schematic editor is open for all three fellows. Okay, sir. Now this is a schematic editor, schematic file for a test bench. Now we need to create a test bench here. So first we need to import our symbol. Okay, so you just create instance. Now I will just show you the shortcuts. So you don't need to again go to another thing, like you can take a shortcut. Means if you press I on your keyboard, instance window will get open. So in instance window, what we get PMOS, NMOS, okay, all the components you can say like a VDC, ground, all the components in the instance window. Okay, so you just listen here what I am saying. I am telling you the shortcut, so design will be completed in less time. So if you type a keyboard I instance, if you type I on keyboard, it will invoke the instance. Okay, and if you type W, wire will be get attached to your cursor, so you can do the wiring then. Okay, and if you type a P, pin will be get port pin will window will get open. Okay, these are the shortcuts. And if you want to rotate that pin, R, so that pin will get rotate. These are the shortcuts you can use. So here I am using the shortcut now. I am typing I for instance. Okay, I am typing I for instance. Okay, so it is lagging somewhat. Now your windows get opened.
All of you type I. Very good. Yes.
Okay, now this window will open, right? Like mine.
Yes. Okay, fine.
Huh. Now, whatever the library you have created, select that library. For example, I have created Chetal underscore day2.design. Sir, mute your mic. Sir. Okay, so select your library. Okay, whatever the library you have created, symbol and whatever the library you have created, symbol for inverter. Okay, selected.
Yes, sir.
Now click on this and click INV, your other file, not a test bench file, your other file. Okay, there is a symbol for that particular thing. So don't go in hurry. Okay, slowly we will go. So INV underscore plane. Don't select test bench cell. Mohammed, you have selected wrongly. You just click there. Yeah, inverter. So inverter symbol we need to take down now. So after selecting that, you can see that symbol is get there, right? Inverter symbol. Pooja, Poonam, have you selected?
Yes, sir.
Okay. Now hide this, and place it in your schematic editor. If you come out of mode, press escape. Good. Okay. Now you can take an instance now. Similarly, vpulse and vdc. So first we will take vdc. So I am typing I. Okay. Now go to the analog lib. Now, if you want to take a MOSFETs, or any active element like that, so you need to select a library like a GPDK 90 or GPDK 180. Okay, just listen this. And if you want to take like a sources, simulation sources, that should be in analog lib. Okay, so to take these particular cells, you need to select that particular library in instances. For example, now I want to take a DC source. So I will select analog lib. Okay, and I will select the source, or you can browse that library also. Okay, if I click on browse, so you can browse that library. So if I want VDC, DC voltage source, VDC. Okay, you can type VDC here in small. VDC. VDC. Okay, so VDC will come and symbol V will become. Close it. Okay, and you can place it in your diagram. Properly you can place it. If you want to rotate the element, you can rotate. Click on that element and press R. Then this cursor will come. Then click on the element again. For example, if I want to rotate this element, I will click on that element. I will press R, and again I will click on that element. Okay, like this. So now we want VDD should be on the bottom side, right? So like this, plus should be on the top. Plus terminal should be on the top. Otherwise, you can take a VDD again. I will just type instance VDC. Okay, if you hide this, for your mouse cursor, that symbol will be get joined, right? And if you press R, that will be get rotated. Okay, so Poonam, just
Yes,
click
sir.
on that VDC. Just click on that VDC.
Yes, sir.
Delete it. Similarly, PC number 8, you delete the VDC. PC number 8 or PC number 7. PC number 7, are you there?
Yes, sir.
You delete your VDC source. Delete. Type I. Now take a VDC. That is selected. VDC selected from analog lib.
Yes, sir.
Hide this. Don't place it until I say that. Okay. You just move up. Pooja. Poonam, you just move up.
Yes, sir.
You can rotate by pressing the R. So positive terminal should be connected to the VDD. Rotate, press R. Okay, PC number 8, you are right. Press R. Don't. Okay, zoom out properly. Poonam, you zoom out properly. Sir, please tell Poonam. Okay, other
Yes,
fellows
sir.
are right now. Now you can take ground also from analog lib. Take G and D, ground. Hide this. And place it like this one time. Again place it one here. Okay. Okay, taken the connections, right? Now take a pulse. Again type I and type VULSE, V pulse. ओके पूनम, आपका विंडो थोड़ा जूम आउट कर लो, मतलब प्रॉपरली वो सिंबल है ना थोड़ा छोटा आएगा, तो प्रॉपरली आप कंपोनेंट प्लेस कर सकोगे.
Yes, sir.
Right, impulse.
Okay, V pulse have you taken? PC number 7, Mohammed has taken. Okay, PC number 7, type, yes, good. Hide this and place like this before input. Poonam, have you placed correctly? Good. Now escape. If you want to come out of any mode, press escape. Good. Now look at my diagram and make a connection. How I am doing? If you want to take a wire, press W only. Shortcut key.
Yes.
If I press a W, one wire is get connected to my cursor. Press a W. Or now you take a wire. If you know how to take a wire. Yes, good. Now you make a connection like this. How I'm making the connections. So I'm connecting this positive of VDC to VDD. I'm connecting this VSS pin to ground. Yes, Mohammed, good. Yes. PC number 7. Good. Now you can connect this input source to inverter. Similarly, this ground to this ground. Okay, similarly this ground to this ground. Okay, made the connections. Mohammed has made the connection. Good. Yes, good. Now we have created the symbol giving the supply voltages. Now to take output, we will need one port. Okay, port pin. So to take a pin, shortcut is P. Press a keyboard key P. After pressing the keyboard key, this window will get open. Create pin. Okay. Go slow. Make a yes.
Press P, Poonam. Okay, you can go for create pin. Okay.
You can go like that. I'm only telling the shortcuts only. You can go by
Yes,
that.
sir.
Right. Name as out. Whatever you want, you can give out also. Now can. But do check the direction.
Okay, PC number 7.
Yes, sir.
So have you typed P or your instance is not showing? Window create pin window is not showing. Yeah, good. Now give the name V out. Okay, and direction should be the output. Okay, hide this and place it like this. Okay, hide this and place it like this.
Do the connections.
Yes, good. Now make a wire connection. Press a W. PC number 7, good. Poonam, good. Mohammed, good. ठीक है. Now after this, check and save. Check and save. Do you know? Right. Check and save. So good. You can check a log window. If you don't get any pop-up, so there will not be any error or warning. Okay, you can check the log window also if you want to see the errors. So here you can see the schematic check is completed with no errors. Good. Now open your window. So all of you are here. Poonam, have you checked? Have you got any errors?
No, sir.
Okay, good. Now we need to edit the properties of the element, like we need to give the source voltages. Okay, just like whatever you have given the yesterday. So I'm selecting this VDC source. Go to your schematic editor. Select VDC. If you want to find, first press escape. If you want to come out of any mode, press escape and then select that element. Then go to the properties. To go to the properties, there is a shortcut key Q. First select the element and then press Q. Mohammed, what happened? Hello?
Hello, sir.
Your voice is not audible.
Am I audible?
Yeah, you are audible now. What happened? Why are not doing? Hello? Okay, you are having maybe network problem. You try to connect it. क्या हो रहा है? तुमचं ते टाकत होतं काय माझं
अभ्यासी पण आली टाइम नहीं है जरा ठीक है मैं सर नहीं तो क्यों देखना पड़ेगा कि सिंबल ठीक से बना चाहिए वो देखना पड़ेगा पहले सिंबल ठीक लगा
Okay, Mohammed, are you connected? Connected है क्या? Maybe net problem आ रहा है उसका.
ऐसा नेट से प्रॉब्लम है अपना सब सॉल्व किया
Keep in chat box means Mohammed, post your problem in chat box. You are not audible and can I click this one?
For other person can test the test bench by giving the input in the defaults.
Okay. Have you connected now? Yeah, connected. Good. Just minimize any desk. Go to your schematic editor. Again, I will show you. Okay. Go to the schematic editor. Minimize any desk. Mohammed. Are you following, Mohammed? So you just move your cursor so that I can understand that you are connected. Just your PC's cursor, you just move it. Yeah, good. Now you select DC source, the upper one DC source. If you want to find out that any element is get selected or not, you just make sure that the solid white line is get around it or not. Select VDC.
1 volt.
Mohammed. Yes, good.
Sir,
Okay.
keeping analog lib only, no, sir, for
Yeah. We have taken that from
library.
analog lib only. Now
Yes.
we need to set the properties. You cancel it, Mohammed. You cancel the Cadence cell. If shortcut is not working for you, you can use another method also, like clicking on that, then right click on that. Properties. Okay.
All of you write the DC voltage.
Sir, how much voltage we have to
Okay.
take?
Now you put the DC voltage 1 there.
Write 1.
Then click OK.
Don't provide voltage at all. Write only 1 and click OK.
Put the DC voltage 1 and OK.
Hello, Mohammed. Press OK.
उसका नेटवर्क इशू आ रहा है अभी.
उसका नेट पर आ रहा है. ठीक है.
Okay. Now connect the sweep, click on the sweep pulse, type Q. Okay.
Like Q. Okay. Define the voltage pulse. Like voltage
Now,
voltage
if you select voltage 1 volt, okay, period 100 nanoseconds, so 100 and only. I am giving the rise time 10 and okay, I am giving the fall time 10 and okay. This kind of analysis you have done yesterday. I have just created the symbols and now giving the supply voltages. Okay, and the pulse width 50 N. So duty cycle will be 100%. 50 N. Okay. So have you followed PC number 7, Poonam? Mohammed?
Sir,
Yes,
sir,
speak.
pulse width is
Yes, sir.
50.
Pulse will be V pulse. What? Again, you repeat.
Sir,
What?
pulse width is 50 or 40, sir.
50 N, because we want a 50% duty cycle now. Period is 100 nanoseconds. So one pulse width I am taking 50 N.
Okay, sir.
नहीं वो पूरा pulse width लेता है पूरा pulse. Okay. Click on OK then.
Then check and save.
Then check and save. Now, yesterday you have followed the simulation, right? The same simulation should be followed here. Okay. Now you set up your DC voltage sources and V pulses. The same analysis should be done here now. Go to launch ADL.
Launch ADL.
Now for AND gate you have NAND gate you have done the analysis like this only, na? So you know how to do this. Now don't go to analog. Okay, just follow me. Just follow me, both of you. Just follow me. Just follow me now. Don't do anything. Okay,
Yes,
okay.
sir.
Mohammed is also in sync. Okay. Mohammed, you make voltage 1 voltage 1. Don't, sir. Let him do. Let him do. Voltage 1 volt. Okay, you give the period 100 N. Yes, give the rise time 10 N. Don't give the delay time. Don't give delay time. $50 N you put 50% duty cycle you want. He applied and
Check
gone.
and save. No problem, sir.
Mohammed, are you following me?
Hello, sir.
Yeah, are you following me?
Yes, sir. I'm following
Good.
you.
Now you
Sir,
launch
I've
8.
added. Yes,
Just
sir.
check and save that.
Okay, sir.
And launch AD. Good. Now follow me. Yes. License should be yes.
Yes. Now follow. Don't go to studio.
Now this is a analog design. Okay, analog design environment tool. Okay, so different kind of analysis we can do in this particular window. Okay, ADE tool. So on the left hand side, you can see there is a design variable section. We will use that section also. This side on the right hand, analysis section is there. So whatever the analysis you take, like a transient analysis, AC analysis, okay. So in the transient analysis, what we do, we check about the delays, like a falling time propagation delay, rising time propagation delay, right? In the AC analysis, what we do, we change the frequency, right? And we give the AC signal, we change the frequency and we observe the frequency response. Okay. such a type of analysis, if you select any analysis, that will appear in this analysis window. Okay. Now, if you want to view the input and output signal, and after selecting those input and output signal, those signal will be available in this output section. Okay. So what I am doing to choose the analysis, here shortcut is there. AC DC analysis. Okay. Choose analysis. Shortcut is there. If you select this, are you following me? Choose analysis. Okay. Poonam? Yes. If you click on this, one window will get appear, right? So in this, you can see different type of analysis is there. TRA means transient analysis. TC means DC analysis. Similarly, different analysis are there. Okay. While looking at particular analysis, we will see that particular analysis. Okay. Now, first transient is default selected. So here 100 nanosecond time period we have given, right? So at least 500 nanosecond we will keep the stop time. Okay. So after 500 nanosecond, that simulator will get stopped. And here you can see the accuracy default like a conservative, moderate, and liberal. Okay. It will decide the speed of the simulator. If I select the conservative, the speed will be very fast. Okay. But accuracy will be less. If I select the moderate thing will be there. Similarly for other thing. So if I press OK here you can see transient analysis get added in the analysis window. Okay.
Press OK.
Got it? So
Sir, I'm getting an error.
Don't put second, only N, right N.
put 500 N there. In stop time, put 500 N.
Yes, sir.
Okay. Mohammed, just wait. I will just show you. Shortcut I need to show you. That's why I am following this.
Okay, done all.
Okay, all of you done. Analysis get added in your analysis window, right? Similarly, if you select a DC here, you can select a DC analysis also. Choose analysis, DC analysis. Like this also you can do. Save DC operating point. Mohammed, choose analysis. Go to that shortcut. Select DC. Now you select DC. Save DC operating point. Yes. Click OK.
Okay. Let me click OK.
Okay. So 2 analysis get added. So if you add 10 analysis will get added in this window. Now we need to select input and output ports. Okay. Now here you can see the symbol setup outputs. Here setup outputs, all of you. Okay. Now if you click on setup outputs, this window will open, setting outputs. Okay. Now here option is there, from design. If you click on from design, it will go into the editor. Okay. Now don't select anything. If you gone into the editor, don't select anything. Otherwise it will select the net. So if you want to do the voltage measurements, then you need to select the net. If I say select, then only select. I am just explaining now. Don't select anything now. If you want to measure the voltage, you need to select the nets. Okay. And if you want to measure the current, you need to select these nodes, like red color nodes are there now. If you want to measure the currents. Okay. So here we want to measure the voltages, input and output voltages. So I will select this net. Net means wire. That blue color wire is now, that is a net. Okay. So I am selecting that wire. After select, now click that. Output wire you click.
Click on output wire.
Good. Only there. Now you click on input wire. Okay. Selected. Okay. Now setting outputs window. Bottom you can see in setting outputs. Bottom one, setting outputs is there. Now 2 nets get added. Vout and net whatever the you are net 5, that is your input net. Okay. In Mohammed, that is net 5, means whatever the net you have selected, according to that, that will be get appear. Okay. Okay. So whatever the net you have selected in my design, it's showing net 4 is my input net. Okay. So if we click on OK here,
Click on OK.
now go to the ADE window.
Yes, ADE window.
Click on OK.
Automatically will change.
Don't select on diagram. Okay. Make sure. Now go to the ADE window, that is on the bottom side. So here you can see 2 analysis and 2 output nodes are get added. Okay. So after doing this, if I click on this netlist and run, here green symbol, here you can see play button.
Green symbol.
Play button, right? If you click on this, what is mean by that? Whatever the netlist we have created, I will show you that netlist also. You click on netlist and run.
Click on netlist and run. Click on green button.
Mohammed, yes.
Yes, all of you are getting output of transient output, right?
Okay. So now split the windows.
Mohammed, go to the output window.
Waveform, bottom one, Mohammed, bottom one. Yes, split the window. Here option is there, splitting. Okay. Now this is get open, right? Now here you can see the transient simulation for this particular design. Yes, yes, yes. Good, Mohammed. Yes. Now different kind of analysis you can do like this only. So I will just minimize this. I will come to this PSF part, PSF window. Okay. Okay, I'm just minimizing the minimize. Okay, minimize your waveform window.
All of you minimize your waveform.
Now that schematic PSF file is there now. Yes, that only. Maximize it. Yes. Okay, drag up, sir. Drag up, all of you, drag up. Up to this point, you are seeing now that is showing. Drag up. Yes. Now wait here. See my screen and wait up to that point. Okay. Poonam, you minimize your waveform window. Poonam, you minimize your waveform window.
Yes, sir.
Now,
After
so here you can see the first file, that is input.scs. Okay, just click on that file, input.scs. So have you click on that file?
yes, sir.
Some window is get opened. Yes. We will just cover, just show you the. For me, it's,
All done.
okay. Have you that netlist is opened? Okay. So
Sir, input SCS is open.
yes. Input PS, that only.
Sir, after clicking on it, it is not opening.
Yes, for. ठीक है, it is a netlist file. Okay, that will be applied as an input to the spectrum. So for me, it's not. I don't know what's the issue here. Okay, those who have got to open that file, there is a netlist file that will act as an input to the simulator. Okay, so just ठीक है, you can close that file. Netlist, just like a spice simulation, you have seen this while doing analog circuit practicals. It's just like a spice simulation file. Okay, some components are there, some analysis is there. If I again click on it, okay, now this file, one time you only click it. So this file is visible to you. Poonam, you re-simulate it.
Yes, sir.
Poonam, you click on input.scs or you can run your simulation again. Your file is open, Poonam. Okay, that fellow. Input.scs is open. Oh, good. Now here you can see the first line is generated for Spectre. Okay. So a Spectre is a one kind of simulator used by the Cadence Virtuoso tool. Okay. So it will simulate our design. So it will take input as your netlist file. What is mean by netlist file? Here you can see. First, they have included this library. Okay. So you have selected this GPDK90 library. So it is included that technology file here. Here you can see that simulator language is a spectral language. So some fellow what they do, some designer what they do, if they know this language, they don't draw the schematic. They just describe your schematic in this language. So here you can see the cell name is inv underscore plane. View name is schematic. Okay. Now here you can see subcircuit. Subcircuit is inv underscore plane, and how the components are placed in that subcircuit. Here you can see like a VDD, VN, Vout, VSS. So this is a netlist description. Okay. So this file will be applied to the input to the Spectre simulator, and that Spectre simulator will give us this simulation. Okay. So this is important. Okay. So all of you got this. So we can conclude our session here. Okay. And after the lunch, we will see the different kind of simulations. Okay. So if you want to practice this, you can practice here. It is for you. So we are giving the lunch break here. Okay. So at 2 o'clock, we will again join and we will do some different kind of analysis. Okay. So if you want to do the practice, you can do practice here.
Or else if you want to go to lunch, you can the session. We will start session at 4. At that time, you can reconnect it again. The system will remain. Okay, we are leaving the session. Thank you all. We are leaving this session.
सरांचं डिझाईन मध्ये चुकलं होतं क्लिअर असतं
नाही सिम्बॉल चुकला सिम्बॉलचं कसं आहे की कसा आपण त्याच्या अंदरची डिझाईन ते राहील